In the latest episode of the series, Secrets of the Dead, scientists unearthed new evidence to determine if volcanoes in India played a role in the extinction of dinosaurs. What did they find out? Let's talk about it. Hi, and welcome to my channel. In this episode of the series, Secrets of the Dead, we learn about the Deccan Traps. These are massive igneous rock formations found in the western part of India. The traps were created by the Deccan volcanic province, which began erupting around 66 million years ago and lasted for approximately 30,000 years. It was one of the largest volcanic events in Earth's history, with an estimated volume of 2 million cubic kilometers of ash, lava, and other volcanic materials spewed into the atmosphere and onto the surface of the Earth. The problem is that this event pretty much lines up with the extinction of the dinosaurs, except for one small detail. Scientists have long debated whether or not these volcanoes caused the extinction of the dinosaurs. Most agree that the asteroid impact in Mexico's Yucatan Peninsula was the main driver behind their extinction, but many believe that the Indian volcanoes could have played a role too. And if so, would the asteroid impact have been a contributing factor, or was it just a coincidence that both happened at roughly the same time? To get some answers, researchers decided to date the volcanic rocks and sediments from multiple locations across the Deccan Traps. They collected 24 samples of volcanic ash layers that were interspersed with sedimentary rocks. Dating these layers will help reveal when the major eruptions occurred and if there were any gaps in the activity. This information will allow us to know if there were hiatuses in the volcanic activity. If so, the asteroid impact may have triggered a significant change in the volcanic activity. And if there were no gaps in the record, then it would suggest that the asteroid impact didn't really affect the volcanic activity at all. Using a technique called argon-argon dating, the team determined that there were 3 major periods of volcanism. The first period lasted from 66.4 to 65.5 million years ago. The second period was from 65.2 to 64.9 million years ago. And finally, the last period of intense volcanic activity was between 64.8 and 64.6 million years ago. They also discovered a 4-year gap between the first and second periods and another 3-year gap between the second and third periods. Next, the researchers wanted to determine if the dates for these periods changed when they analyzed different samples from different locations. After all, they had collected their samples from sites that were hundreds of kilometers apart. If the dates varied between the different sites, it would mean that the dating method wasn't accurate and that they couldn't trust the results. But when they compared the results, they found very little difference between them. This suggested that the dating method was reliable and that the Deccan Traps eruptions followed a consistent timeline regardless of where they sampled. But what did this tell them about the asteroid's impact? Well, the asteroid hit the Earth around 66.05 million years ago, right in the middle of the first period of intense volcanic activity. But the researchers expected to see an interruption in the volcanic record, perhaps a layer of ash deposited during the impact event or a sediment layer that formed as a result of the impact. But when they examined the sections of rock, they saw no evidence of this. There was no gap in the volcanic activity. This means that the asteroid didn't cause a significant change in the volcanic activity. In fact, the team concluded that the asteroid impact probably didn't even play a role in the extinction of the dinosaurs. Instead, the extinction was most likely caused by the environmental fallout from the asteroid impact, such as global cooling, changes in rainfall patterns, and ocean acidification. All of those things combined were likely enough to send the planet into a state of chaos and destabilize the delicately balanced ecosystems that existed at the time. However, the lack of a gap in the volcanic record doesn't completely rule out the possibility that the asteroid triggered the volcanic activity. Perhaps the entire province erupted as a single event. Unfortunately, the resolution of the dating methods used in the study is simply not good enough to detect a possible connection. To test the hypothesis that the asteroid triggered the Deccan Traps eruptions, researchers need to improve the temporal resolution of the dating to pinpoint the timing of the events more precisely. Still, the results from this study can help us understand how volcanoes can shape our world. The Deccan Traps are a great example of how volcanic activity can alter Earth's surface and create vast igneous rock formations. Studying the Deccan Traps can teach us about the mechanics of plate tectonics and the dynamics of magma chambers. Plus, by learning more about how volcanoes work, we can better predict their behavior and mitigate the risks they pose to human populations. So while the research team may not have found the definitive answer they were hoping for, their work does contribute to our overall understanding of the Earth and its processes. And hey, maybe someday we'll discover that volcanoes really were responsible for the extinction of the dinosaurs. Now, speaking of the end of the dinosaurs, if you want to learn more about the asteroid that killed them, check out the episode. Also, be sure to stay updated on all of the awesome content we have coming up next. If you enjoyed this video, hit that like button and share it with your friends. Subscribe to the channel and turn on your notifications, so you never miss an upload. And as always, thank you for watching. One of the most iconic animals to have ever lived, Smilodon, aka the saber-toothed cat, was a formidable predator that roamed North and South America during the Pleistocene epoch. The name Smilodon comes from the Greek word smilos, meaning knife, and odon, meaning tooth. This refers to the most recognizable characteristic of the cat, its extremely long and sharp canine teeth, which could grow up to 30 centimeters long. But what else do we know about this legendary beast? While Smilodon has become synonymous with prehistoric megafauna, it wasn't actually the first of its kind. The earliest known species of saber-toothed cat, Smilodon gracilis, first appeared in North America around 3 million years ago. Over the next few million years, various species of saber-toothed cats would evolve and thrive across the globe, including in South America, Europe, and Asia. However, the Smilodon genus was unique to the Americas. As with most prehistoric creatures, much of what we know about Smilodon comes from fossil evidence. And while fossils are typically thought of as being found preserved in stone, fossilized teeth are actually quite common and are often the only remains of an animal that survive. And the incredible length of their teeth isn't the only thing that sets Smilodon apart from modern cats. Saber-toothed cats are believed to have hunted large mammals, including mastodons, mammoths, and giant ground sloths. Their long teeth would have been perfect for delivering a lethal bite, and their hunting techniques would have been similar to those of modern big cats. However, unlike modern cats, saber-toothed cats were obligate carnivores, meaning that they relied on meat for their survival and wouldn't have eaten plants under normal circumstances. What led to their eventual demise? As with Smilodon, the extinction of other saber-toothed cats is believed to have been caused by a combination of factors. These include changes in climate, the extinction of their prey species, and competition with other predators. Some scientists believe that the most famous Smilodon species, Smilodon fatalis, went extinct around 11,000 years ago due to the onset of the Ice Age. Others argue that it was the competition with other predators, such as dire wolves and short-faced bears, that ultimately led to its downfall. Whatever the reason, the extinction of saber-toothed cats marked the end of an era in the history of felines. Today, only one species of saber-toothed cat remains, the American tiger, whose numbers are sadly dwindling in the wild. Smilodon holds a special place in our collective imagination, and it's easy to see why. Its ferocious appearance and powerful presence have made it a popular figure in books, movies, and TV shows. Whether you're a fan of scary stories or just appreciate the awesomeness of nature, you've probably heard of the Smilodon. So next time you're feeling brave, why not pay homage to the saber-toothed cat by adopting its fierce spirit and showing off your killer smile? Just don't use it to eat your dinner. Thank you for watching.